Hello, my dear students, and welcome to Friday's class notes and lecture and assignment for chemistry. We're going to go to our classroom in Google Classroom, and if you will open up your class stream, you can find what I'm going to cover and your assignment. The coverage for today is how to name and write the formulas for acids and bases. And the notes are here. And I'm working in an instructor version of Google Classroom, and I'm working on my iPad, so the actual steps and procedures may be different from what you actually do, but they should be similar. Here is our topic for the day, and to get it into a usable format so that I can annotate and discuss it, what I do is open it and then go to open a copy and dismiss any warnings and go to share and export, which gives me another opportunity to send a copy. In this case, what I do is send a copy to my files. You can save it where you want. I'll save it here on this file for my presentation application, which on my Apple iPad I like to use Keynote. Now, I've already saved it, so I'm going to save it again and get out of this, go back to my classroom so that I have everything I need, and go to my presentation and open it up. And this is 19 quick slides. It won't take us long, and the assignment is short too. But I want to discuss naming and writing formulas for acids and bases. And so far, we've already done naming and writing formulas for ionic compounds, and then naming and writing formulas for covalent molecular compounds. There's some special considerations for acids and bases, and probably the worst example they could have given is the example of formic acid, because formic acid is a trivial name for this compound. It is found in the bite of fire ants. The genus and species for the Texas fire ant is Solenopsis invictus, and they have a very painful bite because they release this organic acid, whose formal name and official IUPAC name, International Union of Pure and Applied Chemistry name, is actually methanoic acid. And formic acid is a trivial name that really shouldn't be used, and there are some additional rules for organic acids like formic acid, which is the simplest one, that we will not be covering in this class. So I don't know why they chose the fire ants formic acid poison or venom that's in their bites as an example. So let's go to our main topic, and that is covering the 3 rules for naming acids. But that, of course, brings up the first question of what's an acid. And we'll look at some different definitions of acids. 3 main ones. There's classical Arrhenius acid and Bronsted-Lowry acid and a Lewis acid, as we learn those different definitions. But our simplest definition of an acid is anything that produces H+. And, when we're measuring acidity, we use what? The pH scale. And we'll do a lab about that. We'll be doing several labs about it. But H+ is the hydrogen ion, and it's also known as a proton, Because what happened? A hydrogen atom lost an electron, right? So an electron is pulled off, and we get H+. Well, this hydrogen ion, positively charged cation, remember hydrogen element number one proton, one electron. You lose the electron, what's left? One proton. So another word for a hydrogen ion or proton or H+, those terms all mean the same thing. And if you produce or give off H+, for our purposes today, that means you are an acid. There's, like I say, some other definitions of acids later. What they're showing you here is an example of some etched glass, because if you take glass, and I have a lab where we do this, but I don't like working with hydrofluoric acid because it's so dangerous. But there is an acid. I have to store it in plastic bottles because it eats glass, dissolves glass. But if you ever see frosted glass and etched glass, what they do is they cover it with, in my lab, we use contact paper, and then you draw a picture on it, a flower, for example, and then after you draw this, you cut everything away. You use a razor blade to cut out the different parts that are not drawn, and then you're left with contact paper sticking to your glass. That's your diagram. And we brush on hydrofluoric acid and let it sit. It doesn't take long, an hour or two. Some of the commercial safer preparations you buy at like Michael's or MJ Designs and hobby shops, you would leave on overnight, and then we just rinse it off with water, then clean the contact paper off, and what we're left with is some etched glass. So, this is an acid, HF. It's called hydrofluoric acid, and we'll cover that naming next. So, the rule is if you have an ion that ends in "ide." So what would that be? Chloride, bromide, iodide. We'll see an example of sulfide. It would be a 2-, of course. Then what you do is you add the prefix hydro and change the "ide" to "ic." So this would become hydrochloric acid, a very common laboratory acid. We've used it. Hydrobromic acid, hydroiodic acid, sulfuric acid. So these have very straightforward ways of being named. These are commonly what we call binary acids, where we only have two components, as in hydrochloric acid. We've got the hydrogen atom and the chloride ion. The other two rules involve polyatomic ions. If you have a polyatomic ion ending in "ite," for example, nitrite or sulfite, that would be 2-. Then you have an acid that you would call, it becomes the us acid. So, for example, this one would become nitrous acid, followed by the word acid. This one would become sulfurous acid, and so forth. So the ite salt, or anion, becomes the us, O-U-S, acid. And more commonly, anions ending in "ate," for example, nitrate, it's not NO2-, it's NO3-. We learned about how to name these when we were naming polyatomic acids. Or sulfate, which is SO4 2-. These become the ic acid. So nitrate would become HNO3. We've used nitric acid in the lab. This is nitric acid, followed by the word acid. Okay, so the 8 salt, or the 8 anion, when combined with hydrogen, becomes the ic acid. And similarly, this sulfate becomes another common laboratory acid, sulfuric acid. And, these were salts. If I were to make sodium nitrate, combine it with sodium, this would become sodium nitrate, or this would become sodium sulfate. Okay, but when I put the H plus cation, the hydrogen ion, with these different polyatomic anions, then I've produced an acid. Because remember, an acid is anything that produces H plus. So here's a quick summary of the 3 rules. If I have a simple binary acid, attached to an anion ending in ide, chloride, bromide, fluoride, sulfide, nitride, any of those, then it becomes an ic acid, but it has a prefix of hydro, as in hydrochloric acid. If it ends in, I'm going to go to the one that's more common, and that is if it ends in ate, as in nitrate, sulfate, phosphate, it becomes the ic acid. So, for example, phosphate would become phosphoric acid, another common laboratory acid. And then finally, the ites, like sulfite, becomes the us acid, as in OUS ending, and becomes sulfurous acid. 3 quick rules, and we're done. So, if you know the formula, you now have rules for writing the acid. What happens if you're giving, the name and you want to determine the formula? Well, you just kind of do the reverse. Okay, so if you are given hydrobromic acid, it's got the hydro in front, so it must have the H from the hydro, and it must be made out of bromide, the bromide anion. So H plus Br minus gives me this hydrobromic acid. There's my cation, and that makes it an acid. There's my anion. So these are basically ionic compounds with a few special rules designating them as acids. Here are some common laboratory acids. We use them all. Hydrochloric, that's, that rule number 1. Sulfuric acid, nitric acid are very common. That's the 8 acid becoming the the 8 salt or 8 anion becoming the ic acid. Acetic acid is an organic acid. You know it as vinegar in a weak solution. And phosphoric acid is, again, coming from the phosphate anion. And carbonic acid from the carbonate anion. We don't have nitrous or sulfurous or some of the other acids that use the other rule. These are just common ones used in the lab. Carbonic acid is also what's formed in soft drinks, and is responsible for the bubbles of CO2, because you can combine water with carbon dioxide to form carbonic acid. We'll learn about some of these things when we talk about reactions coming up soon. So we talked about acids. What about bases? Well, bases are named just like any other ionic compound. That of course brings up, the question, what's a base? And for our purposes today, a base is anything that produces a hydroxide, because acids were anything that produced H plus. And here's something curious: if you have an acid and a base, you combine them to form a salt. We don't have the counterions on here, plus water, H2O. I sometimes write water HOH to indicate that water itself can break down and dissociate into hydrogen ions or protons plus hydroxide ions. This is an acid, this is a base, and for our definition, anything that produces this hydroxide ion is a base. Okay, so a good example is aluminum hydroxide. Aluminum is a group 3 metal. It forms only a +3 ion, so we have aluminum 3+. And if we combine that with hydroxide, you would need 3 to make a neutral ionic compound, in this case a base, because the anion is the hydroxide anion, plus 3 OH minuses. You're going to produce aluminum hydroxide. But I need 3 of these, and of course when we have a polyatomic ion, we put it in parentheses. I can't write aluminum and then hydroxide with 3, because this means 1 aluminum, 1 oxygen, and 3 hydrogens. I need 3 of the hydroxides. So I put parentheses around this species, the hydroxide anion. That's what defines a base. Bases are very common in our everyday usage. Sodium hydroxide is used to make paper. It's also used and better known as lye, and used as a drain cleaner, and it's used to saponify lipids and make soap. Saponify to make soap. You should have done a lab in your younger days in elementary school or junior high where you actually make your own soap. You start with lipids, fats, and you add some weak sodium hydroxide, and it will do something called saponify those lipids to make soap. And it's also known as lye, which makes a great oven cleaner, because when you add this sodium hydroxide, or NaOH, sodium hydroxide, to baked on grease, it saponifies them and basically turns them to soap, and hydrolyzes things too, does something called base hydrolysis of tough baked on grime. There are many other ones, potassium hydroxide, ammonium hydroxide, but we will encounter those later. So just quickly, some sample test questions. The name for H2S, this is a hydrosulfuric acid, or hydrosulfic acid, because we changed the sulfide to ic. I would call it hydrosulfic acid, but hydrosulfuric acid. So this isn't the best example because they've used a common or trivial name, not an official name, or followed the official rules. Bad question. That's the problem when you know more than sometimes the people who wrote these questions. The chemical formula for chlorous acid, and this is not one of the more common one, but this comes from chlorite, and the chlorite anion is ClO2-. Okay, so it would be HClO2. You would need a chart of the polyatomic ions so that you knew that this was the chlorite anion. And remember, the ite salt or the ite anion becomes the us acid. Okay, that was the second rule. And our final slide, and then we'll quickly go over the assignment, is the correct name for NH4OH. This is 2 separate polyatomic ions, the ammonium ion and the hydroxide ion. This is a very common base. It's formed when you dissolve ammonia gas in water. So when you buy ammonia at the store, what you're really buying is this substance which is ammonium hydroxide. And so that concludes our discussion. So if I may, I will go back to our classroom and go to classwork and assignments and see the assignment, the accompanying assignment that reviews these terms and drives them home. And here it is, a review of concepts and terms for naming and writing formulas for acids and bases. However you want to open it up, however you want to get to it so it turns into an editable form. Usually once it's here, in most PCs and Chromebooks, there are 3 dots at the top right. And so you will open a new window, and then you can save it. Now this one's I've already saved to my files here, and I want to open it so that I have the ability to annotate it with my Apple Pencil, and this is how I have to do it. So here's our assignment that's been saved, and it looks like this, and I will enlarge it slightly and go through and help you with some of the material. An acid is a compound, and I'm reading along. You can open it up yourself and see. I have another screen open where I can read the paragraph over here. Oops, didn't mean to do that. But an acid is a compound that contains one or more hydrogen atoms. Atoms, and produces hydrogen ions. And I apologize for my, and that of course is H plus ions. When dissolved in water. That's our definition of an acid. And there are rules for naming acids. For example, HBr is called hydrobromic acid, whereas HNO3 is called nitric acid. And a base is an ionic compound that produces hydroxide ions. That's our definition. Also known as OH minus ions. And in the same way as the bases are named in the same way as other ionic compounds, and that is the name of the cation followed by the name of the anion. And of course, to be a base, this anion must be the hydroxide anion. So if we move on to our true-false, a compound that contains hydrogen atoms will be an acid when dissolved in water. That's sometimes true. Other compounds contain hydrogen atoms and don't become acids, like many organic compounds like methane, CH4, contains hydrogen atoms, but it doesn't become an acid because it doesn't have a dissociable hydrogen ion attached to it. An acid contains one or more hydroxide ions. That's never true. That's the definition of a base. And chemists have a special system for naming bases. That's never true because they're basically ionic compounds named the same way as ionic compounds. And in this short 3-section matching, an acid is a compound containing hydrogen ions that ionizes. That's that ionizable or dissociable hydrogen ion to yield hydrogen ions in solution, so A. And a base is a compound that produces hydroxide ions in water, and so that would be C. And an aqueous solution is a solution in which the solvent is water. So again, that would be B. So ACB, Alpha Charlie Bravo. And we're almost done. We'll get to the most complex part, which is naming and given the formula, writing the name, and given the name, writing the formula. So magnesium hydroxide, I need magnesium. It's a group 2 metal, so it's +2. The hydroxide ion is -1, so I'm going to need 2 of these, MgOH2. When you buy it in solution at Walmart, it's called milk of magnesia. Hydrofluoric acid is a binary acid using the fluoride ion. That's the acid that etches glass. Phosphoric acid is unusual. You can find it in that table back there. And that the phosphate ion has a -3 charge. So this is called a triprotic acid because it has 3 protons that it can produce. And lithium hydroxide would be lithium Li, which is group 1 +1 hydroxide. This is element number 3, very small element, wonderful pharmacological effects, a first-line drug for treating depression, at least in the old days. Lithium hydroxide, it's making a comeback, but OH is minus, lithium is plus, 1-to-1 ratio. So this one is potassium, and the OH is a hydroxide anion, so this is potassium hydroxide. Potassium hydroxide, like sodium hydroxide, also passes for Li. HI is hydro, that's a Y, not an X. Sorry, I'm using my pencil, Apple Pencil here. Hydroiodic, iodine, iodide, the ide becomes ic, iodic, and we add the word acid. And finally, this is the sulfate anion, and SO4 minus, 2 minus. So this H2SO4 becomes the ic acid of the 8 salt. So sulfuric acid, H2SO4. That concludes our discussion. I want to mention a couple of other things, and that is we will be posting the lab discussions for those virtual students very soon, first thing tomorrow, mid-morning tomorrow. And we will, of course, they'll be available for those of you face-to-face who either missed class or didn't do your work in class when we had the discussions in class. So, one other note I'd like to add is that for my face-to-face students who are used to virtual Mondays, there will be no virtual Monday this Monday. Due to the number of virtual days we've had this week, we want to come in. I'll try to get a lab ready, but fortunately I haven't been able to go to school and I haven't prepped a lab. I don't know what we'll do this Monday. Probably move on to the last topic, and then we'll do labs the rest of the week, and we finished our unit, so we'll be having a test next Friday, and I'll announce that on the Google Classroom tomorrow. Students will come to school Monday. Virtual students, of course, will continue to be virtual and will not be on campus Monday, but we will not have a virtual Monday for our face-to-face students. You need to go ahead and come to school. Catch the bus, arrange a ride, or do what you have to do. And then we'll probably go back to the virtual Mondays. The following Monday, though, I haven't heard. As soon as I hear, you will hear. So, that's it for this lecture. I hope that you all stay safe and stay warm, and I hope to see you all soon. Goodbye now.